In the previous class, we understood the concept of virtual short and the conditions in which you can apply virtual short. Next, virtual ground, which is a special case of virtual short, that is also discussed. Now let us have a look at various inverting, non-inverting amplifier circuits and some typical points of observation in those circuits. The very first inverting amplifier circuit. So I draw the circuit this way, R1, R2, oh, inverting amplifier I said, no? So it is a non-inverting. Let me take connect this one to ground and here VI, V output. This is how I draw the circuit. The same circuit I am redrawing in this fashion. Both are one and the same. Check it. See, output to inverting terminal, we have the resistor R1. Output to inverting input terminal R1 and inverting input terminal to VI, there is a resistor R2. So a resistor R2 is in between inverting input terminal and V input. Both are one and the same. Okay. Even we need not worry about showing this infinite input impedance. Most of the times what we see is, right, people sometimes write without this open circuited terminals between inverting and non-inverting terminal. Doesn't matter. Okay. Now onwards what I do is I apply virtual short assuming infinite gain, that is ideal op amp I am taking, and what is the procedure I told? Apply virtual short, then take the node equation at the inverting terminal so that we get the output voltage or the gain equation, whatever we wish. So this circuit and this circuit both are one and the same. And here I wrote R1. Sometimes people write it like RF. It is known as the feedback resistor. You see, if R1 is not present, then there is no connection from output to inverting terminal. There is no feedback. Whether R2 is present or not, if R1 is not present, there is no feedback from output to inverting terminal. That's why we call R1 as the feedback resistor. Right? Sometimes we write even RF. Doesn't matter. So anyway, I am following one notation. It is R1. R1. Next, how to find V output? Due to virtual short or virtual ground, which is a special case of virtual short. So due to virtual short here, it is 0 volts. Next, let me take it as node A or node KCL at the inverting input terminal. KCL at node A. I am just taking that as node A. Okay, node A. Now it doesn't matter. Okay, so 0 minus Vi by R2 plus 0 minus V output by R1 is equal to 0. So Vi by R2 is equal to minus V output by R1, or I can write V output is equal to minus R1 by R2 into Vi. Very, very simple point. Or the gain V output by Vi is equal to minus R1 by R2. We know it. A very, very simple thing. Okay. In the previous section, we observed how complex the equations were appearing and all. Later, by taking AOL, A open loop gain A is equal to infinity, how simple we can take the things. Okay, this is the idea. Fine. Next point. Here, one point of observation is, if you look at voltage across R1, see, one end of R1 is connected at the output and other end is virtually connected to ground, which means it looks like R1 is connected to ground virtually, not physically. Virtually it is connected to ground, which means voltage across R1 can be taken as our output. voltage across feedback path looking from output to input. If you observe from output to input, voltage across the feedback path can be considered as your output. Okay. For that, for better understanding, what I am doing is I am redrawing the same circuit. Now I am not showing the infinite input impedance between inverting and non-inverting terminals. Doesn't matter. R1, R2, VI, and non-inverting terminal is connected to ground. Due to virtual short, this is 0 volts. Let me take this current as I2 and this current as I1. Okay, then you see I1 is equal to minus I2. We know I1 is equal to minus I2. What is I1? I can write it is, or what is I2? Vi minus 0 by R2. Then what about V output? I said voltage across R1 or voltage at this point with respect to ground, or voltage at this point with respect to virtual ground. Voltage across R1 is my output. But what is I1, friends? It is minus Vi by R2 multiplied with R1. However you do, we get it. Earlier nodal analysis, here also nodal analysis only. Okay. So in case of inverting amplifier, voltage across the feedback path looking from output to input can be taken as your output. This is one interesting point of observation. So I am writing that statement. In case of inverting amplifier, if the non-inverting terminal is perfectly connected to ground, then voltage across feedback path looking from output to input is equal to V naught output voltage. Okay, we can take that statement. Very, very interesting point here. Okay, keep it aside. The next circuit, right? This is how we can take. Now onwards, what I do is apply virtual short, take the node equation as I mentioned. So many times I said so. Suppose the inverting amplifier minus plus I have some load resistor. And what is V output? Is there any change in the procedure? No. Generally, people think like V output means R1 is parallel to RL, which is absolutely wrong. Okay, let us go with the regular procedure. Due to virtual short, it is 0 volts. Next, let me take it as node A. KCL at node A. What do we get? That is 0 minus Vi by R2 plus 0 minus V output by R1 is equal to 0, which implies V output is equal to minus R1 by R2 into Vi. There is no change in the output equation. Generally, people, what they think is R1 is parallel with RL, which is absolutely wrong, which is a wrong concept of, right, if you really understand networks. Okay, see here, for that, for better understanding, I'm taking one example, okay, of here in the next page I take it here. Anyway, the output is independent of RL. As far as the op amp is concerned, we know the output voltage is independent of RL. Just I am writing here, I will prove it. We know output voltage of op amp is independent of RL. I said, due to infinite input impedance, the current entering into any of the input terminals of the op amp is zero, and due to zero output resistance, output voltage is independent of RL. That's what I said in the very beginning session. Okay, so for better understanding of this, let me take one example. Some 10 kilo ohm I am taking R1, R2, 1K, and input is 1 volt. Without load resistor I am taking. So if you take this particular circuit, due to virtual short, it is 0 volts. And let me take some current I1. What is the current that is flowing? 1 minus 0 by 1K, it is 1 milliampere. The same 1 milliampere will be flowing like this only. Is there any other current possible? No. Whatever, even though I write I2 earlier, I wrote I2 is equal to minus I1, or whatever I1 is coming from the source, the same current will flow through, will be flowing towards the output terminal. The same 1 milliampere is flowing. Okay. Anyway, what is V output? Voltage across the feedback path looking from this direction. Okay, from output to input. So that is minus 10 volts, or output is equal to minus 10K by 1K into VI. It is minus 10 volts. You can take. Or what is V output? It is minus I1 into R1, that is minus 1 milliampere into 10 kilo ohm. However you do, you get the same result. Okay, done. Now, okay, the next point, I am connecting some load resistor here. Some 2 kilo ohm load resistor I connected. 10K, 1K, 1 volt. Is there any change in the V output equation? No. This current is virtual short. It is 0 volts. So 1 milliampere, the same 1 milliampere is flowing here. It does not change. And V output voltage across the feedback path are, as I said previously, it remains as minus 10 only. Okay. Then what about the current through this? Definitely, right, if I take some current, right, it is a negative current will be going like this. It is, this current is 10 by 2K, it is 5 milliampere. Earlier, enter 1 milliampere is flowing into the op amp. Now, what is the current that is flowing into the op amp? I can say it is 6 milliampere. Is it not so? The current that is entering into the output terminal of op amp will vary. Reality is, we know here output side 0 output resistance, I said here I can take a current source, sorry, voltage source, dependent voltage source, A into VD, we wrote. And what is its value? Its value is minus 10, no doubt about it. Right here, you may be thinking like, okay, A is approaching infinity and VD is approaching. When A approaches infinity, that time V minus approaches V plus, means VD is approaching 0. So A into VD here, as A approaches infinity, that time VD is approaching 0. What is the value of infinity into 0? Or it is also written like 0 by 0. It always leads to non-zero finite value. We are well aware of it. And what is that non-zero finite means? That is nothing but minus 10 volts. Okay, limit theta tends to 0, sin theta by theta. Okay, there it is 1. or limit theta tends to 0. Okay, 10 sine theta by theta, what is its value? It is 10. Is it not so? Or if this limit is not there, what we write? 0 by 0, it looks like, mathematically speaking. But it always leads to a non-zero finite value. That's what you can see here. It is leading to, in this, it is right. It is a, you will get a finite value here. What is that value? It need not be positive. It can be even negative. Also, it is, what is that finite value? Minus 10 in this case. Okay, and here also the same source we can show. Same, that's value is voltage source value does not change. And here a voltage source without RL. Here RL is infinity. Here RL is equal to some 2K. RL is infinity, that's why IL is 0. Here RL is 2K and IL is equal to minus 5 milliampere. That's it. It doesn't mean that this 2K is parallel to 10K. It is meaningless. It is a coincidence that voltage across the 10K is equal to voltage across RL. That's it. It doesn't mean that 10K is parallel with 2 kilo ohm. Two different circuits. See, when do you say two components or two resistors are parallel, means see, it is some RA and it is RB. Here I can comfortably say these two are parallel. I is the current coming and this current is some IA, this is IB, and again IA and IB are joining together and it is I. Do you see such kind of scenario here? No. Here, in this case, what is happening? If you observe this, from it is 1K, later due to virtual short, it is 0 volts, next to 10K, and whatever the, and 1 volt. So, this current I am saying 1 milliampere, the same 1 milliampere is coming like this. After that, here we have another 2K, and it is going to a voltage source of value minus 10 volts. That is the idea here. So in this direction, some 5 milliamperes is coming and both are joining together and it is 6 milliampere. As it is 0 volts, physically it is not connected. Right here, the voltage at this point is 0. That is the speciality of op-amp. It doesn't mean that the 10K resistor is parallel with 2K. Okay, here 10K and 2K, this circuit is different from 10K parallel with 2K. Okay, here the current may be 5 milliampere and here the current is, both are entering this point. If I take it so, then 1 milliampere. If that is the case, it is 6 milliampere is released. 6 milliamps has to enter. Do you see such scenario here? If that is the case, this and this should be shorted. Is it so? Definitely not. You cannot short them. It is a coincidence that voltage across 10K is equal to voltage across 2K. It doesn't mean that 10K is parallel with 2K. Okay, please do observe this. Most of the students do mistake here. Okay, so 10K parallel with 2K means this is the scenario. Here it is a coincidence. One end of 10K and 2K are connected here, but other ends are not physically connected. Okay, this is the thing. Okay, so voltage RL is not influencing our output voltage equation as far as inverting amplifier is concerned. Please do remember this. Next, What is V output? See, is there any current that is possible into the non-inverting terminal of op amp? It is simply 0. Means voltage across R3 will be 0. Means this voltage and here the voltages are one and the same. There is nothing to worry about the resistor R3. The circuit is same as that of the original circuit. Here it is 0 volts, means here also it is 0 volts, as the op amp doesn't entertain any current to enter into its input terminals. R1, R2, VI, it is minus R1 by R2 into VI. As simple as that. Next. I have an op amp circuit like this. Find V output. So due to virtual short, it is 0 volts. Here it is 0 volts and here it is 0 volts. Is there any current that is possible through R3? Simply 0. Means R3 does not play any role. So this circuit is equivalent to this. Okay. So R3 is not playing any role here. Okay. Finally, I'm just writing one more circuit. These are all small observations only. R1, R2, R3, R4, R5, V output, VI. Suppose you see some kind of some circuit like this in the exam. What is the gain? Output is independent of R5. R4 does not play any role. Ideal op amp, no current enters into the input terminal. So voltage across R5 is 0. This is 0 volts, and here due to virtual short it is 0 volts. R3 does not play any role, and simply minus R1 by R2 into VI. That's it. Okay. This is how we can understand the very different scenarios of inverting amplifier circuit. Next, non-inverting amplifier. And one more thing I can write here. Yes. R1, R2, VI, R3. Yes, friends. See, is there any current that is possible into the input terminal of op amp? 0. Means the voltage here and the voltage here are one and the same. So due to virtual short, it is 0 volts, means here also it is 0 volts. If that is the case, what is the voltage here? 0 volts only. So R3 does not play any role. I need not worry about this. Observe this. So that this circuit is same as that of this only. Okay, I forgot to tell this circuit. Very simple, you can understand it. Nothing to worry. And let me write this here. Some R6. Okay. Just to confuse us, sometimes they may give so many resistors. We need to understand whether they really play any role or not. Okay. So that's about inverting amplifier and non-inverting amplifier circuits. The circuit I started with is like this. The same circuit I can redraw this way. Both are one and the same. Next, what do we do? Procedure I told, virtual short and take the node equation. Due to virtual short, this voltage is Vi. Let me take it as node A, and KCL at node A. Vi minus 0 by R2 plus Vi minus V output by R1 is equal to 0. So Vi into 1 by R2 plus 1 by R1 is equal to V output by R1. Bring this R1 to the right hand side. So Vi into R1 by R2 plus 1 is equal to V output. It is as simple as that. Apply virtual short and take the node equation. We got the result. Okay, very simple. And in this case, is it possible to say V output is equal to voltage across R1? Absolutely not. Because this terminal is not virtually connected to ground. Okay, here it is connected to, virtually it is connected to Vi, but not to ground. Okay, but one thing we can say, the same circuit can be even, right? We can write like this anyway. Here I wrote it, thus, right? We can plus minus R1, R2, Vi. This one only, right? Nothing else. Now, due to virtual short, it is Vi, means this voltage is Vi. So, what is V output? Voltage across R1 plus Vi. V output is equal to voltage across R1 plus Vi. Earlier, voltage across R1 or voltage across feedback path was taken as output in inverting amplifier. But here, voltage across the feedback path plus Vi, as far as this circuit is concerned. See the difference between inverting and non-inverting amplifier circuits. And here also, if you have some load resistor, doesn't matter, right? That is the load resistor you are connecting will not influence our system's response. Anyway, output of op amp is independent of RL. That is the speciality of op amp. Output remains the same. Okay. Next. What is output? Is there any current that is possible in this direction? No. No current enters into input terminal of op amp. So, is there any role of this R3 here? No. So, I need not worry about this R3. So, this circuit is same as that of the basic circuit only. So, this is same as that of our regular circuit. Is it not so? So, output gain equation remains the same. Our V output is equal to 1 plus R1 by R2 into Vi. It's as simple as that. Whereas Find V output in this case. Okay, here I can write the current entering here is 0, but from Vi to ground there is a scope for the current to flow like this. So from input to ground, here no current is there, but from input to ground there is a current possible. So what about V plus then? V plus, or voltage at the non-inverting terminal. Voltage division rule. V plus is equal to Vi into R4 by R3 plus R4. Okay. Once we know V plus, then due to virtual short, V plus is appearing here. V minus is equal to V plus. So once I know this voltage, then what is V output? V output is equal to 1 plus R1 by R2 into voltage at the inverting or non-inverting terminal. So that is 1 plus. So earlier problem, what we observed, V output is equal to 1 plus R1 by R2 into voltage at inverting or non-inverting terminal. Okay, voltage at the non-inverting terminal means V plus, V plus, that is Vi here. Okay, the same thing, R1 by R2 into Vi multiplied with R4 by R3 plus R4. This is how we can write the output equation. In this circuit, suppose R1 is equal to R2 is equal to R3 is equal to R4 is equal to R. All the resistors are equal. Then what is V output? 1 plus R by R into Vi into R by R plus R. It is 2 Vi by 2, that is Vi. Means this circuit behaves like a voltage follower. Okay. So if I draw a circuit like this with all equal resistors, then output is equal to input. Above circuit behaves like a gain is equal to 1. So behaves like a voltage follower. A very, very simple thing. Okay. Next, let us have a look at some problems asked in the previous papers. An ideal op-amp is an ideal voltage controlled voltage source. Option B is correct. Basically, it is a voltage controlled voltage source. Voltage amplifier I told now. So if I take its equivalent circuit, what we have rating A into VD. This is the equivalent circuit. So a dependent voltage source. So that's voltage source, and which is controlled by voltage. VD is the differential input voltage. That's why what we write, it is a voltage source controlled by voltage. Voltage controlled voltage source. Ideal op-amp has the following characteristics. It has infinite input impedance, infinite gain, AOL stands for open loop gain, and zero output resistance. A is correct. An ideal op-amp is used to make an inverting amplifier. The two input terminals of the op-amp are at the same potential because the open loop gain of the op-amp is infinity. As A is approaching, open loop gain is approaching infinity, then V minus is equal to V plus minus V output by A. So V minus will approach V plus, or both are equal, both are at the same potential, because open loop gain is tending towards infinity. We need not worry about the other answers. A very basic circuit, right? What is the gain of the circuit? Right, output to inverting terminal feedback connection, and V output is equal to minus R by R into 1 volt minus 1 volt. Option A. So basic level question. See this. The inverting op amp shown in figure has the open loop gain of 100. Then the closed loop gain. We did the same problem actually, 10K, 1K, etc. Then what is the closed loop gain? It is equal to minus R2 by R1 by, according to this notation, 1 plus 1 by A open loop gain into 1 plus R2 by R1. It is, anyway, I did the same example, I think so, right? 1 plus 1 by 100 into 1 plus 10K by 1K. It is minus 9.01 something, you will get it. So minus 9 is the answer. The output voltage shown in figure is, see, sorry, one point I forgot to tell you. Here, is it possible to apply virtual short and all? Generally, what do you think? Applied due to virtual short, it is 0. Then node equation, RB output is minus R2 by R1 into Vs. If there are, the gain is minus R2 by R1, minus 10. It looks like minus 10. But what happened? As the gain is less, you can't apply virtual short. You have to go with exact method. We should be very careful. Okay, the output voltage shown in figure in volts is close to. Okay, it's an inverting amplifier. What is V output? Generally, right, we take ideal, assuming ideal op amp, due to virtual short, it is 0 volts. Output is minus 2K by 1K into 10 minus 20 volts. But is it possible? The power supplies are plus 15 and minus 15, which is less than V output minimum. Not possible. Means what is possible? It is minus 15 volts. Option B is correct. If that is the case, implies V minus is also not equal to 0. If you want, you can calculate what it might be. We know the procedure, of course. Okay, out of curiosity, I want to find what is V minus. Here it is minus 15 volts, 2K, 1K, 10 volts. It is V minus, sorry, not V plus, V minus. So node A, KCL at node A. Then it is V minus minus 10 by 1K plus V minus minus of minus plus 15 by 2K is equal to 0. Kilo and kilo cancel. 3V minus by 2 is equal to, here it is 10 minus 15 by 2, it is 5 by 2. So what is V minus, friends? 2 to cancel, it is 5 by 3. Is it not so? So V minus is not equal to 0. V minus is not equal to 0. V minus is equal to 5 by 3 volts. So voltage at the non-inverting terminal is 0. Voltage at the inverting terminal is how much do you get? 1.67 volts, like that. So inverting terminal voltage is dominating non-inverting terminal. Output is equal to minus V saturation. No doubt about it. That is valid. Okay, it's not like any input of your choice can be applicable. You can apply virtual short as long as the output is not reaching its extreme values. We know that. Next, assuming the ideal op amp to be ideal, the voltage gain of the amplifier shown below. Just to confuse us, I gave the circuit like this. If you observe this, okay, generally what people think is, okay, due to virtual short it is 0, and again some nodal analysis, something there, right? Nothing to worry. The same circuit can be redrawn like this. See, the non-inverting terminal is connected to ground. From input to inverting terminal, this is R1, and output to inverting terminal, it is R2, and output to ground, R3. This is V output and it is Vi. R3 is like load resistor. Then what is the gain? ACL closed loop gain is equal to minus R2 by R1. Oh, not R3 by R1. It is R2 by R1. Okay. It's a very, very simple question. We need not break our head too much on this question. Just to confuse us, they change the shapes. Okay. It is something like, see, I may draw some circuit on the board, and if you are asked to rig it up on the breadboard or springboard, what you will do? Different students will show different views. Ultimately, the connection remains the same. Okay. That's what they are doing here. Okay. Overall connections, they do not change, but the appearance wise, they look different. Okay, given that the op amp is ideal, the output voltage is okay. Very basic level question. It is 1 plus 2R by R into 2 volts. It is 6 volts. Okay, within seconds we write it. So an ideal op amp of figure has a very poor open loop gain, okay, 45, but is otherwise ideal. The gain of the amplifier, see, the gain is less. So what you have to do is the exact method. The gain, closed loop gain, it is equal to 1 plus 8k by 2k by 1 plus 1 by a 45 into 1 plus 8k by 2k. How much do you get? It is 2 fours. So 5 by 1 plus 5 by 45. 5 ones, 5 nines. It is equal to 45 by 10 or 4.5. Option D is correct. 10. In the circuit shown below, all the components are ideal. If Vi is equal to 2 volts, the current I0 sourced by the op amp is. What is the current coming out of the op amp output? It's very simple thing. Anyway, what is let me take this is V output. What is V output, friends? It is 1 plus 1k by 1k into Vi is 2, so it is 4 volts. V output is 4 volts. Okay, so it is 2 volts due to virtual short. It is 2 volts and it is 4 volts. And we can take some current here. Let me take this current as IL. What is IL? 4 by 1 kilo ohm, that is 4 milliampere. Is it not so? And there is a current possible like this, higher potential to lower potential I am writing. Okay. And what about this current? This current is 4 minus 2 by, right, or let me take this current as I1. I1 is equal to 4 minus 2 by 1k, that is 2 milliampere. So what is I naught? It is I1 plus IL. It is 6 milliamperes. So the current coming out of op amp, it is 6 milliampere. So very simple. An op amp based circuit is implemented as shown below. In the circuit, assume the op amp to be ideal. The voltage in volts corrected to 1 decimal place at node A. Okay, what is the voltage at this point? Okay, connected to the negative input terminal of the op amp as indicated in figure is. Okay, what is the voltage? Generally, what do you expect? Due to virtual short, it is 0. But what they're asking it. So let us see the output then. What is V output? It is equal to, right, inverting amplifier. It is minus 31k by 1k into 1 volt. It is minus 31 volt. Is it possible? It is less than V output minimum. What is V output minimum, friends? Minus 15. So what is the possible value of output? Minus 15. So if it is 0, then output should be minus 31 volt. As output is not minus 31, this voltage cannot be 0. Then it is something else. How do we find it? We know that procedure so many times, right? Even earlier also I mentioned it. So minus 15 volts, 31k, 1k and 1 volt. So it is V minus. If I let me take it as node A, KCL at node A, V minus minus 1 by 1k plus V minus of minus plus 15 by 31k is equal to 0. Okay. Then V minus k and k anyway cancel. So V plus V by V minus by 31, that is 32 V minus by 31 is equal to 1 minus 15 by 31. It is a 16 by 31. So 31 31 cancel, V minus is equal to 1 by 2 volts or 0.5 volt. Okay, corrected to one decimal place, so it is 0.5 volt. Once you understand the concepts I told before start of the problems, just like that you can do the problems. Okay, once you understand the concept, there is these are all very simple things. Okay, assuming that the op amp in the circuit shown below is ideal, the output is, okay, ideal op amp they said. And generally what you take, virtual short and nodal analysis. But here, is it possible to take the virtual short? Voltage at the non-inverting terminal is 1 volt, voltage at the inverting terminal is 0. So you cannot apply a virtual short. Means instead of op amp, it behaves like a comparator. And what do we think? See then, VA or V plus, right? V plus is equal to 1 volt and V minus is equal to 0. So V plus is greater than V minus, and hence as V plus is greater than V minus, the output should be equal to V saturation, that is 12 volts. You cannot apply virtual short here because this terminal is connected to ground. Okay, that's it. It is as simple as that. Next, let the magnitude of the gain in the inverting op amp amplifier circuit shown be X with switch S1 open. Okay, when S1 is open, the gain is X. When S1 is closed, the magnitude of the gain becomes, okay, right. If S1 is open, then what is X? This R and R will be in series. So the gain 1 I am writing V output by VI. It is equal to minus R plus R by R. These two resistors will be in series. It is minus 2. Okay, let that be X. No issues. X is equal to minus 2. When S is closed, the corresponding gain, S is closed means what is the circuit, friends? It is a short circuit parallel with R, it is short circuit only. So we can take it like this, R VI V output. R A2 is equal to minus R by R, it is minus 1. So what is A2 then? X by 2. Okay, what they're asking? The magnitude of the gain becomes, okay, so it becomes X by 2. Is it not so? Okay, so option A is correct. So very simple thing. Just to confuse us, to be frank, nothing is there in this problem. Now look at this question. In the circuit given below, the op amp is ideal. The output voltage V0 in volts is, what is the output voltage? Okay. So first point is we should find V1. People generally think like entire current is flowing like this, which is absolutely wrong. Here also some current is flowing now. If that is the case, first thing is let us take this voltage V1. How do we find V1? And one more thing, this 10K is connected. Is there any role of this 10K? This current is 0. 10K does not play any role. So I can remove this. So this voltage is 0. So due to virtual short, it is also 0 volts. Or I am just redrawing the circuit. It's a non-inverting terminal is connected to ground. We output 20K, 10K and 2 volts, 20K, 20K. First of all, once I know the voltage at this point, due to virtual short, see this, due to virtual short, it is 0 volts. And this voltage is mentioned as V1. Okay, so whatever the current that comes here, it is splitting into two parts. I cannot say 20K and 20K are in series, right? It's not like entire current is going like this, which is absolutely wrong. For that, I am taking this node equation. Okay, if I take the node equation KCL at let me take this as node A. V1 minus here the voltage is 2 by 20K plus here V1 minus 0 by 20K plus V1 minus 0 by 10K is equal to 0. Okay, just for namesake I wrote the current directions, nothing to worry about it. So. Okay, so V1 by 20, V1 by 20, anyway kilo and kilo cancel. V1 by 20 plus V1 by 20, V1 by 10, V1 by 10 plus V1 by 10, V1 by 5. V1 by 5 is equal to 2 by 20. Okay, 5 fours. So V1 is equal to 1 by 2 volts. Once I get V1, means once I know this voltage V1, then what is output voltage? It's an inverting amplifier. No? So V output is equal to minus 20K by 10K into V1. It is minus 2 into 1 by 2. Answer is minus 1. Such a simple question. See, this 10K is not playing any role, right, which tries to confuse us. Again, people generally what they take here, V1 is equal to 1 volt they will take. But it is not 1 volt, it is 1 by 2 volts. Right? That's how you can be trapped. Next, a resistance temperature detector RTD is connected to a circuit instrumentation paper. That's why they wrote RTD, etc. As shown in the figure. Assuming that op-amp to be ideal, if V output is equal to 2 volts, then the value of X is, what might be the value of X? Okay. So anyway here, due to virtual short, it is 0 volts. We know that. Okay. Then how to find the gain of this circuit? For that, anyway, V output is given, right? And let me take the node equation here. What can we write? 0 minus 12 by R into 1 plus X plus 0 minus of minus 12 by R plus 0 minus 2 by R is equal to 0, in which a unknown parameter is simply X. Just like that we can find. So let me take it as node A. KCL at node A. So 0 minus 12 by R into 1 plus X plus 0 minus of minus, that is plus 12 by R plus 0 minus 2 by R is equal to 0. I can cancel R here. Then further, minus 12 by 1 plus X is equal to Okay, 2 minus 12 or anything you can write, or 2 minus 12, that is minus 10. So 1 plus x is equal to 1.2, implies x is equal to 0.2. Okay, that's it. So that is as simple as that. Next. In the circuit shown, assuming that the op amp is ideal, the bridge output voltage in millivolts for delta is equal to 0.05. Okay, what is V output they are asking? See this. If you observe this circuit, so in this no current flows like this. Means from this direction, whatever the current comes, entire current goes like this only. Let me take this current I, and this current is something like I1, and this current is something like I2. Means this current is again I. Is it not so? Once you understand that, things get over. And what is I? Anyway, this is 1 volt, right? Due to virtual short, this is also 1 volt. So I is equal to 1 by 50 amperes. Okay. Here 1 volt, it is 0, and the current flowing is I over I value we have got. And if you observe the resistance between these two terminals, what it is, 250 into 1 plus delta plus 250 into 1 minus delta, that is 500 ohms. Is it not so? And similarly, what is the resistance looking in this direction? It is 250 into 1 minus delta plus 250 into 1 plus delta. That is again 500 ohms. Which means I1 is equal to I2 is equal to I by 2. No doubt about it. Where I is equal to 1 by 50 amperes. I by 2 means it is 1 by 100 ohms. I1 is equal to 1 by 100 ohms. I2 is equal to 1 by 100. 0.1. 1 by 100 means, okay, 10 milliampere. I1 is equal to I2 is equal to 10 milliampere. Then what is V output? V output is, right, the voltage between these two terminals. Means I2 into 250 into 1 plus delta minus I1 into 250 into 1 minus delta. Okay. So V output is equal to I2 into 250 into 1 plus delta minus I2 means it is just nothing but I by 2 only. Right, why to write more steps? I'm just writing I by 2 minus I by 2 into 250 into 1 minus delta. Okay, so what do we get? I into 250 into delta we get. Check it. I by 2 250, I by 2 250 cancel. I by 2 250 delta plus I by 2 250 delta. What is I? It is 1 by 50 into 250 into delta is 5 by 100, I can write it, or 0.05. So what do we get? 5 fives, and it is 0.25 volts. Okay, that's it. This is how we can do this problem. Okay, that's the next topic. Okay, let us do some more problems in the next section. These are all not at all tough. It's all about how much you practice and how much fast you are able to observe the circuits.